whenever you have triangles which don't have enough information, for example, if I covered this triangle and only tried to solve for the small triangle, there are absolutely no side lengths that I can work with. So for a triangle like this and the last couple of questions in your Unit 15 guide, you're going to be expected to use some algebra. So for this particular triangle, our first step is going to be to come up with expressions for BC, okay? And this is, first of all, this question is similar to a unit guide question. The reason why we are using BC, we're trying to solve for H, that's our end result, and the side length BC is common to both triangles. It's common to the smaller right angle triangle, and it's common to the large right angle triangle, okay? So first of all, we're going to consider triangle ACD. So first of all, we're going to consider triangle ACD. So this is my big triangle. Triangle ACD is my big triangle. So if I let angle A be my starting point, tan of angle A, so tan of 58 degrees, because 58 degrees is my starting point, that's going to be equal to all of this. This is my opposite. Side H is my opposite, all over. I don't know side length BC, so I'm going to let BC be BC. BC plus, I know that this part of the whole side length AC is 1700. It's one of the only side lengths that I know. So I have a situation here. Because I want to, remember my end result is to get an expression for BC because BC is common to both triangles. What I'm going to do right now is cross multiply, okay? So I have all of this in the denominator, BC plus 1700 multiplied by tan 58 degrees is going to be equal to, when we cross multiply the H is going to be multiplied by 1. So is going to be equal to H by itself. Always remember what your end result is. I want to isolate my BC by itself. Okay? So first of all, I want to detach this tan 58. I want to take it away from the BC. So I'm going to divide both sides. Divide both sides by tan 58 degrees so that I can cancel the tan 58. So BC, what else is attached to the BC that I need to get rid of? The 1700. However, we needed to divide the tan 58 because it has been multiplied. The 1700 has been added to BC. So, if you can see this, BC plus 1700 is now equal to H over tan 58. The only thing left to do is get rid of this 1700. Get rid of the 1700. So this hasn't been multiplied, it's been added. So what is the opposite of adding? Subtracting. So BC is going to be H equal to H over tan 58 degrees minus 1700. Minus 1700. So that's my first expression for BC that I'm going to be using. And this is in terms of the big triangle. That looks complicated, but when you do a couple of examples like this, it's going to be pretty straightforward what your steps are. Okay, so now I'm going to look at the small triangle. So we're looking at small triangle, the small triangle within the large triangle. So BCD. Remember, we didn't have any side lengths. However, I knew angle B was 67 degrees, and I know I'm trying to solve for H. So with the smaller triangle, it's much more simple. So we're going to consider the triangle BCD. And this time angle B is my starting point. So I know that tan of 67 degrees is going to be equal to my opposite over hypotenuse, which is opposite. Because I don't know this side length, I'm just going to let the side length be represented by BC. Can someone tell me what my next step is going to be to isolate that BC? What do I have to do? What should I do next? Yep, Kevin? Cross multiply. So I have BC times tan 67 degrees is going to be equal to H times 1, which is just H. Very last thing that I have to do, because I'm trying to isolate my BC, we're going to divide both sides by tan 67 degrees. So I have a final answer that BC is going to be equal to H over tan 67 degrees. BC is equal to H over tan 67. So I have an expression for BC with my larger triangle, and I have an expression for BC with my smaller triangle. Okay, I have two expressions for BC. Does anyone have any guess how I'm going to solve now, what I'm going to do? Does anyone know? Girls, are you paying attention back there? Okay, so let me just explain one thing. What are we solving for? What is our end result? What's the end thing that we're looking for? The side length H. The side length H is our end result. So you'll notice this expression for BC has the letter H in it. And my other expression for BC also has the letter H in it. So what we're going to do is set both of those equations equal to each other, and we're going to solve for H. So, very last step, I'm going to let BC be equal to BC. We're going to let BC be equal to BC. I'm going to rewind this later on if you missed anything, so you can really see what we're doing. So I'm going to let the two expressions be equal to each other. That means that H over 1078 minus 1700 is going to be equal to H over 1067 degrees. So those two expressions are now equal to each other. And the biggest tip I can give you, you want to put all the H's on the same side. We want to put all the H's on the same side. So I'm going to move this over to the other side. Is it 1058? Sorry, that should be 1058. So H over 1058 subtract H over 1067 degrees is going to be equal to the 1700. Instead of being negative 1700, that's going to move over to the other side, so that's going to be a positive 1700. Okay? Remember, we are not punching anything into the calculator yet. The next step is to look at the left-hand side, and I notice I have a common H for both of those terms. So what I'm going to do is take the common H out.